Now we have this question. We have this diagram with two circles squeezed into a box of rectangular shape. And the base is 80 centimeters, the height is x centimeters. We are now asked to calculate x and s the area. Using the knowledge of properties of circle and tangent, we will solve this one easily. Now, we know that the diameter is 16 centimeters here. And in this place too, it's 10 centimeters. And at this point where they join, the total distance is the sum of the radii. So this place is 5, this place is 8 centimeters. So the total here is 13 centimeters. 13 centimeters. Again, from this place to this place is 8 centimeters. From this place to this place is 5 centimeters. I believe it's clear now. With this, we also know one thing. Let's make this place. Let's make this place. We know that this place is 13 centimeters. We can calculate B. We can calculate A now. From here, let's see. We can see that from this place to this place is 5. From this place to this place is 8. So we can find B by saying 5 plus B plus 8 is equal to 18. So from here we can see that B is equal to 18 minus 13, which is 5 centimeters. So we have a right angle triangle here. You can see this place, this place. So from here you can say this place is 13. This place is 5 centimeters. So A, let's calculate A. A will be square root of 13 square minus 5 square. Using Pythagoras theorem. And this will give us 12 centimeters. So we know this place will be 12 centimeters now. This place 5. So we can find this place in x now. From this place to this place, we need the radius of this place. So we have 8 centimeters here. This place is for here. From here to here is 5 centimeters. Radius of this other side. So A is 12. So x will be equal to 5 plus A plus 8, which is 5 plus 12 plus 8, which is 25 centimeters. Now we have gotten x. X, area of rectangle. We can get it now by multiplying x by 18, which is 25 times 18, and that is 450 centimeters. The distance between two circles is 14 centimeters. The diameters of the circles are 8 centimeters and 12 centimeters. Calculate the length of A, direct common tangent to both circles. B, transverse common tangent to both circles. Give answers to two significant figures. So we are going to have it like this. And we were told that the distance between them is 14 centimeters. So we have 14 centimeters. And the diameter of the smaller circle is 8. For the bigger one is 12. So we are now asked to calculate the tangents, direct tangents. So let's draw direct tangent now. So it can be from here, it can be from here. Anyone. The length will be equal. Now, we use some properties we know about circle and tangents. From this place to this place, it will be half of the diameter, that will be 40 centimeters. From this place to this place, it will be 6 centimeters. Another thing we know about it is this one is perpendicular. This one too is perpendicular. Now, we can do it in two ways. We can either draw a, what we call a parallel line to this one, or we can draw a parallel line to this one. A parallel line to this one from here, or a parallel line to this one from here. So we look at it from both ways. Now let's draw parallel line to the tangents. Here. Now, if this is parallel to this, you know one thing, this will serve as transversal. This angle here will be equal to this angle here. This angle here will be equal to this angle here. You know that the two will be 180, so this one too will be. So automatically they have given us a parallelogram and given a rectangle because the four angles are right angles. So which means that this place is 4. The distance from here to here 2 will be 4 centimeters. And this place will be 2 centimeters. That is 1. Then this place to this place is 14 centimeters. You can see. So we can bring our triangle out like this. This is 2 centimeters. This is 14 centimeters. So this place will be, using Pythagoras theorem, will be square root of 14 squared minus 2 squared. And that will give us. So it gives us 13.8 approximately. And you are told to give an answer to two significant figures. So we can say that the tangent is equal to, by the time we convert this one, it's going to give us approximately 14 centimeters. Now, like I said, you can also draw a parallel line to this one. Let's do this from here. You see? So, this place is 4. So, from here to here 2 is 4. And this place will be 2 centimeters now. And this place to this place will be 14 centimeters. So, this place, you can see the right angle here. So, we will also come back to make this place root of 14 squared minus 2 squared. Because this is the hypotenuse, it's not facing the right angle there. So, you can see, either way you look at it, you are going to get the same answer. Now, let's go to B part. Now, let's try to get the value of the transverse tangent. Looking at this, you can pick any of the two. Now, if I should pick this one, I have this. This is 4. Now, from here to here, 2 is 6. So, looking at this, I can draw a parallel line to this upward or downward. Now, let me draw it upward now. So that I can you can see. So, which means that, like the other one, this one increases it. The parallel line I drew increases this line here. This place to this place is perpendicular. This one, you can see. As I have drawn this one now, it's perpendicular. So the distance from here to here will be 6 centimeters. You can see. This is 6 centimeters. So everything here will become 10 centimeters. 4 plus 6. Okay, just do this. You can see. I drew a parallel line to this one from here. You can see. So this one is perpendicular here. This one too will be perpendicular here. For this angle here is smaller than 90. This one too is smaller than 90. So this one here is the 90 degrees. So for me to find this length, I just need to find this one. And I can do that by saying 10. This is parallel line to the tangent, and then this is 40. And this is the perpendicular line. So at the end of the day, this one is going to give me square root of 14 squared minus 10 squared, applying Pythagoras theorem. So that will be, let me see. So it gives me 9.8 centimeters. So 9.8 centimeters. So B is approximately 9.8 centimeters. These are two significant figures. So I've shown you the two ways you can do the first one. Let's see the other way you can do the second one. So for this one, two tangents are equal because they originate from, you can see from the same point. Here, this is 6, this is 6. This will be 4 here now. You can see. And by the time you look at it, this is perpendicular, this is perpendicular, perpendicular here. Here too, vertically opposite angles are equal. You can see. The vertically opposite angles here are equal. So, you can see. Now, I can have two similar triangles. So let me just take this one and this one. So let me remove this and this one now, this tangent. So let me face one tangent. Let me face one tangent. So look at what I have now. This angle here is perpendicular, this one is perpendicular. These two angles are equal. Vertically opposite angles are equal. Automatically it means that this angle here will be equal to this angle here. This angle here will be equal to this angle here. That's it. So even by the time you look at it, I just want to hint you. The angle here and this, the two of them will give us 360 degrees. Just for your knowledge. This one and this one are equal. This one here and this one are equal. So we have two similar triangles. So what does that imply? It means that this one here and this one will be in the same proportion as this one and this one. Now let's look at what it will be. If I have 4 here, I have 6 here. So let's call this x. Let's call this one y. So x plus y is equal to 14. So x over y will be equal to 4 over 6, which is 2 over 3. So if I define x now, we're going to find x now. So y will be equal to 3 over 2x. So x plus 3 over 2x is equal to 14. So 5 over 2x is equal to 14. X is equal to 28 over 5, which is 5 points. So y will be equal to, so that is 14, and that should be 8.4. 8.4 centimeters. So you can see that we have two portions of the tangent. So let's call this piece A and let's call this piece B. From what we have now, we can see that A and 4 centimeters will make up x. So we can now say that A squared is equal to 5.6 squared minus 4 squared. B 8.4 squared minus 6 squared. So from there we can get A, we can get B. So let me get it. So I'm calculating. I got this portion A as 3.92, B as 5.88. And you know the sum of A and B gives us the total length of the tangents. So transverse tangent is equal to A plus B, which is 3.92 plus 5.88, and that is 9.8, approximately 9.8 centimeters. Even you might not need to find it. Once you have gotten A, you just use your proportion to get it. The ratio of A to B is 2 to 3. So A to the whole length will be 2 to 5. So you can just say A times 5 over 2, and that is going to be 3.92 times 5 over 2. So let's go like this. So that also gives us 9.8. So knowledge of ratio and proportion, you get it right straight once. So that's the way to handle this. Let's look at another question. A continuous belt passes round two pulleys of diameter 16 cm and 24 cm. The distance between the centers of the pulleys is 20 cm. Calculate correct to three significant figures. The total length of the belt. We have two pulleys. 1 and 2. Just like the expression we just finished now. And the diameters are 16, 24 centimeters. We are now told that a belt, continuous belt, passes around the two pulleys. So a portion of the belt will be like a tangent. round it like this. The other one too, move round. I was also told that distance between the two centers is 20 centimeters. Now, remember, we know how to get this straight. You know how to get it easily now. From here to here is this. Same here. Same here. Same here. Now, for us to get this, we can draw a parallel to this, just like the one we did the other time. And here. And this base is 8, and this base is 12. So for our triangle now, here, for us to get this base, it's just going to be, this base is 4, this base is 20. This base will just be square root of 20 squared minus 4 squared. Very simple. Just making it easy. So this base will be square root of 20 squared minus 4 squared. And the same thing here too. So this base will be square root of 20 squared minus 4 squared. Before I go on, let's do something. Let's label this. A, B, C, D. So the total length of the belt will be equal to arc AB plus the straight line BC plus arc CD plus the straight line DA. That is length of belt. Will be equal to AB plus BC plus CD plus DA. You can see. Now, BC and DA, you can easily get that one now. So BC equals DA, and that gives us. So this one gives me 19.6 centimeters. Now let's find the length of this and this. This base is 4, this base is 20. We have known this one too. This is the 20 here. And I want to find the angle subtended here. And the angle subtended here. This angle here, I can find it, and this angle here, I can find it. Let me make it up. This is right hand. So this, let me call this one alpha. Let's call this one. So this one is alpha here, this one is alpha here. So let's get alpha. So the 2 will be 2 alpha. So I need the 2 alpha, I need the 2 beta here. Let's get alpha. Sin alpha. Sin alpha is equal to 4 over 20, which is 0.2. So alpha is equal to arc sine 0.2. And that is. Now, I am able to get alpha. And so 2 alpha here is 23.1 approximately. So from here I was able to get beta. That is 90 minus this one. So 2 beta is this. Now, let's now break it down for ease. So this base is 23.1 degrees. This base is 156.9. And if you look at it, the curve I'm looking for, the angle here, this is the angle I actually need. This one here. For this one, this angle is what I actually need. This one here, I can easily find here by subtracting this one from 360. And as I told you, this one here, and this one here, and this one here will be 360 degrees. This one here and this one. Now let's just continue. Don't let me digress. Now, I have it. One day. This base will be 360 minus 156.9 degrees. This base here. So, this base here is 203.1 degrees. This side. For me to calculate this side, you know this place is 90 degrees from the parallel I drew. This one here. that this side is going to give me 156.9 degrees. So the angles I need are this one and this one. And I already showed you this, so that once you get this one, you have already gotten your answers. This one will give you this one. And from here, you get this one directly. So you don't need to stress yourself. So you can get this one, you have gotten all the things. So always try to get this one. For your diagram, you know which one to get for each. Now from here, let's now find length of the portion AB. AB now will be equal to 156.9 over 360 times 2 pi. What are the radius of this part? This one is 8. CD will be equal to 203.1 over 360 times 2 pi times 12. Given the standard value for pi, so let's use it. So I have gotten AB, I have gotten CD, and we had already gotten BC and DA. So total length now, length of belt, as we have gotten before, is going to AB, that is 21.91, plus BC 19.6, plus CD 42.54, plus DA 19.6. And let's see what that gives. So on adding everything, I got 103.65. So as you are told that we should get the answer to 3 significant figures. Right? I got it here. So you can see it's very simple. Just break it down from the basics and you get your answers. So please, I need your attention on this one because of the diagram. In the diagram, ASRCB represents a piece of string over pulley of radius 10 cm in a vertical plane. O is the center of the pulley, and AMB is a horizontal straight line touching the pulley at M. Angle SAB is 90 degrees. Sorry. Angle SAB is 90 degrees, and the angle TBA is 60 degrees. A, calculate 1, the obtuse angle SOT. Arc SRT, this one, and BT. So B, find correct to the nearest centimeter the length of the string. So we have to take it in turns now. Now you know that this place is 60 degrees. This is 90 degrees. So now this is tangent. So let's draw this one parallel to the tangent. You see, we have to find this angle A1. Angle, calculate the obtuse angle SOT. This angle. This is the obtuse. This side is reflex. It's more than 180 degrees. So since we know this one is 90 degrees here, this one is 90 degrees here, this is 60 degrees. Now, by the time you look at this, this one too is 90 degrees. Everything in this place will be 360 degrees. So here, let's find this angle MOT, this one, plus 90 degrees, plus 90 degrees, plus 60 degrees is equal to 360 degrees. Because that's the total angle in a quadrilateral. Therefore, angle MOT will be equal to 360 minus 240. Minus 240 degrees. And that's going to give us 120 degrees. So the angle MOT here is 120 degrees. Now, for us to find angle SOT, so we are going to find angle SOT now. So, angle SOT, this one here, plus this 90 degrees here, plus 90 degrees, plus 120 degrees, plus angle MOT, let me put it that way, is equal to 360 degrees. Angle at the point. Look at what I'm saying. This one here, plus this one, we have gotten this one to be 120 degrees. This one, and this one gives us. So SOT plus 90 degrees plus 120 degrees giving us 316. So angle SO2 is equal to 360 degrees minus 210 degrees. That is 150. So you can see how easy it is to handle that one. Now we have to find arc SRT. That one is also easy. For us to find arc SRT is equal to, that is the length of this place, is equal to this angle 150 degrees over 360 degrees. And we know the radius to be 10. So times 2 times 22 over 7 times r. That's what that means. So you see, for the first one, angle, we have gotten down. For the second one, at SRT, we have gotten down. So we have 26.19. So we can easily keep that one now. This one is 150 degrees. 26.19 centimeter. Now let's find BT. Now to find BT, it's very simple. We have the right angle here. Angle between the tangent and the radius. And then we have another one here. So by the time we draw a line from this place, we are going to have two congruent angles. This one, this one. So automatically, this angle here will be bisected. We noted this in our theorem. And this one too will be bisected. This one too will be 66. So for us to find TB, we have this now. This place we have 10. This place we have 30. So TB. So we are going to have a triangle like this. TB. Oh, this is 10. This is 30 degrees. So TB, let me see, 10 over TB is going to give us tan 30 degrees, which is 1 over 3. So TB is going to be 10 root 3. So this one is 10 root 3. So we have already gotten the value for the A part. Now we have to calculate to the nearest centimeter the length of the string. Now we have to find the length of the string. From the question, we are told that ASRTB represents a piece of string. That is, we are going to find the length of the total from A to S to R to T to B. So that means length of string will be equal to AS plus SRT plus TB. This one is just a line from A to B that passes through N. As then contacted is equal to N. So we know the value of our AS. AS is equal to the radius for this diagram. So that is 10. AS is radius. It's radius. SRT, we got that one to be 26.19. BT, we got that one to be 10 root 3. And by the time we add everything, let's see what it gives. So in addition, I got 53.51 centimeter. And we are told to get it to the nearest centimeter. So that's approximately